Welcome back. Today we are going to be looking at transformation of trig graphs. And what's nice about this lesson is that a lot of what we're going to see today is very similar to what we've already seen with different functions and those transformations, with just a couple differences. So let's dive in and take a look at what kinds of transformations we can have with a cosine or sine function. You'll notice up here the two functions with the variables put in where they would appear. In the last video, we talked about b values, okay? If you are going to have a horizontal shift, real quick, it's important to notice the double parentheses here. So if we just have cosine of 2x, we do not need double parentheses. But if we have cosine of 2 and then we're also shifting our graph to the, let's just say by 90 degrees. So we have x plus 90 as an example. I'm going to have the double parentheses there with the horizontal shift in its own parentheses. That's really important because then the b value gets applied to the entire variable and shift, and you won't be able to get the graph you're trying to get if you don't do that. So. All right, so let's take a look at each of these individually now. And since I was just talking about it, let's just start with horizontal shift. Okay, so horizontal shifts work just like they do with our other functions that we've seen, where the sign that you use is the opposite of the movement that you have on your graph. So a positive h value will move your function to the left. Negative will move to the right. Okay, so just like the other functions we've seen. Now, what's kind of cool is that because of this, because we're able to apply horizontal shifts and our sine and cosine functions actually have the same shape, except that we note that where they start is unique to each of them. So cosine's shape, right, it will be like from here up to here, a bowl, and sine starts at 0 and goes up and then swoops down. But if we take one of those and we shift it strategically, we can land them right on top of each other because they do have the same overall pattern. So because of that, it's possible for a certain situation, like when you get into word problems later in your independent practice and through the unit, when we're seeing applications of these, it's always possible to write a function to model a scenario in both sine and cosine. Your horizontal shift will just be different for each of them. Now, when we're doing that, you will have other parameters that will be the same for each of them, whether you choose sine or cosine for the scenario, because what's not changing is the overall height of the graph and where the graph is, so whether it's been shifted up or down. So those parameters that we'll talk about in a second will be the same for sine or cosine for the same, again, for the modeling the same scenario. All right, so the next one we're going to look at is amplitude. We're going to work backwards here for a second. Amplitude we can think of as just like B was a way of stretching the graph, sort of either horizontally stretching or compressing. A also can stretch our graph, but it stretches the hills. It stretches it up and down vertically. Okay? And specifically what the amplitude relates to is the distance between the maximum point and the midline of our function, as well as the distance between the minimum point and our midline. And the midline on the parent function is just the x-axis. Okay, so if we haven't moved our graph up or down, that midline, which cuts the graph in half horizontally, will be the x-axis. So the amplitude again refers to the distance between the highest and lowest points and that midline. Okay, so for an a value greater than 1, okay, the distance between the max or minimum and the midline increases. When a is a fraction less than 1 but greater than 0, so it's still positive, then that distance is going to decrease. So those hills sort of will flatten, right? So you'll see your curve be flatter instead of more stretched and skinny, okay? If a is less than 0, this will flip our graph, just like it did with other functions we've studied. And beyond that, you'll also have to look for the number. So for example, -3 would flip and stretch vertically, but -1/2 would flip and compress or cause that distance to shrink. Okay? So you can have a combination of those things. The last parameter we'll look at is the k-value, and you probably already guessed this, again, using what you know from former units, but the k-value is responsible for vertical movement. And just like in other functions, the k-value follows the sign that you're given. So positive goes up, negative goes down. The midline is also found from the k-value. So that midline that I was just talking about, that runs right through the middle of our graph horizontally, that can be found by just looking at k. So because that in the parent function is normally at 0, if we put a number at the end now, instead of having nothing there, we're shifting it up, that's where the midline goes to. Okay. It's also important to note that the midline combined with your amplitude can help you find the maximums and the minimums, because the max and min are the same distance from the midline, and that distance is the amplitude. Okay. So your midline, let's just make a little note of this, plus or minus the amplitude will give you those max and minimum values. Okay. So let's put this into practice. Let's take a look at just a couple examples here. All right, so for this first one, we're going to just fill in the blanks for the different variables. Okay, I'm first going to note where, just like zoom in here and look at a couple points. So I've got 0, 3 is right here. My maximum y value is 5, and my minimum y value is 1. Okay. And so halfway between 5 and 1 is that 3. So the 3 is our midline. So let's just sketch that in there. So that means since our midline is at y equals 3, our k value is 3. Now we're going to take a look at the amplitude. So the amplitude is just this vertical distance, or this vertical distance, either one. It should be the same distance. So the distance from 1 to 3 or from 3 to 5 is 2. So our amplitude is 2. So it got stretched. It's twice as skinny as our parent function would be. Okay. Now notice in here we have space for a b value, but we don't have any space after the x for a horizontal shift. And we can see why by looking at our graph. We can see that the starting point of our sine waves pattern, right, that sideways S, is still on the axis. So it hasn't been moved left or right. Or it could have been, but it would be a multiple of 360 because every time you move it 360, it'll look like no shift has taken place. So we aren't going to include a horizontal shift here. But we are going to include a B value. So we need to look and see how many times the sine wave cycles through from 0 up to, in this case, we're working with radians, so 2 pi. So let's just visually count our sine wave patterns. So we've got 1, 2, 3, 4. So it cycles through the sine pattern 4 times in one turn of the unit circle, or one cycle. So 4 is our B value. Okay, let's look at one more example. This time we're going to sketch the graph. Now, I'm not going to even use Desmos. I'm going to kind of show you my thought process for trying to graph by hand. Desmos is a great tool for checking your work though, especially if you're stuck. But we can do this without relying on Desmos. We just have to be strategic about how we start and where we make connections between the graph and the equation. So the first thing I'm going to do is start with my midline. So this cosine graph has been shifted down 1. So meaning the midline is right here at -1. Now my amplitude is what I'm going to look at next. My amplitude is 5, meaning the distance between the midline and the max and the mins is 5. So I'm going to count up 5. From -1 is 4. Y equals 4, and I'm just going to make that a dashed line. And then down 5 would bring me to -6. Again, I'm just going to make that a dashed line so I can see that that's just as high and as low as I'm going to go when I draw my curve. Okay, the last thing I'm going to look at, since there's no horizontal shift, will be my B value. Okay, so for my B value, it's 2, which means between 0 and 360, I do 2 of these, right? So what I'm going to do is I'm just going to draw a line down the middle here through 180, and I'm going to draw from between 0 and 180, I'm going to have a full cosine pattern, and then I'll have a second one over here. Okay. And so remember, the pattern of cosine is that it starts at 0, 1, right? But it's also been shifted down 1 and stretched. Okay. So if my starting point is at 0, 1, we can always just plug in 0 also if you're not sure. So if we plug in 0 here, just to make sure we're doing everything correctly, if we plug in 0, we get 5 times the cosine of 0 minus 1. The cosine at 0 is 1. So 5 times 1 minus 1 is equal to 4. So 0, 4. Just showing you how you can check if you're not sure. Now that we've done that, we can see that we have that point that we just plotted is right on that dashed line, right? So when you think back to what we were just doing, we had already found where our max and mins are going to go. So that checks out, and hopefully going forward you can recognize those patterns, but that's just a way to see, oh yeah, yep, that point that I just verified is right where the max is. It shouldn't be above that because there shouldn't be any points above that maximum line right there, okay? So then halfway would be 90. At halfway, it's at its lowest point. And then at the end, at 180, it's at its highest point again. Halfway between our highest and lowest points, those x values, halfway between there is where it should go through your midline. So we should have these points here are both halfway between. So those are the quarters, right? So those are your 5. Remember the 5 key points that we saw in a previous lesson? Those are your 5 key points. Okay, and we can repeat that over here on the other side. So our last maximum is at 360. We've got a minimum at 270, and then halfway between each of those sets, we'll go through that midline. So now we've got all those key points. Now we can just go ahead and kind of just do our best to roughly sketch a cosine wave. That wasn't that great, but that's okay. And there we've got our cosine wave. Okay, so now lastly, just things to think about when you're going ahead and trying problems like this in the independent practice. Things to think about when looking at transformations. Where is the midline? If it helps, draw a horizontal line there. I think that really helps. What is the amplitude? Draw horizontal lines at those y values, like I just did in the example. And then think of what is the length of one complete cycle. Use that to help you get those 5 anchor points. And doing that, you can successfully, hopefully, graph a sine or cosine wave without using Desmos. Okay, so now make sure you go ahead and practice and let your teacher know if you've got any questions.